Hi, welcome back. Our previous lesson was on deriving the indifference map. Today we'll be moving on to other types of indifference curves. So we recall that in our previous lesson, we derived our indifference curves based on several assumptions such as completeness, transitivity, non-satiation, and diminishing marginal rate of substitution. And we also said that this account for the shape of the indifference curve sloping downwards and having a bowed inward shape. In some situation, some of these assumptions may not hold. So when this happens, the shape of the indifference curve may also change. So let's look at a few examples of these cases. So the first case that we'll be looking at is perfect substitute. So we've mentioned before that when two goods are substitute, you can consume one in place of the other. So for example, when you have tea and you have coffee, you can take tea or you can take coffee. Now, perfect substitute simply means that these two goods are not just used in place of each other, but they are substituted for each other at a constant rate. Now, if we go back to a typical indifference curve, we mentioned in our previous lesson that diminishing marginal rate of substitution means the slope along this indifference curve is not constant. So for instance, the slope at this point is different from the slope at this point and is different from the slope at this point. So this simply means that the consumer's rate of substituting one good for another, it changes along the indifference curve. Now, this is not the case for perfect substitute. So let's look at an example. If a consumer is choosing between maybe basmati rice and a generic brand of rice, so if we assume that for this consumer, one bowl of basmati rice is always exactly equal to one bowl of a generic brand, then it means that this consumer is willing to always trade one bowl of basmati rice for a bowl of a generic brand. Now, in economic terms, what we mean is that the marginal rate of substitution of basmati rice for the generic brand is constant. So we mentioned that the marginal rate of substitution is also the slope, and in this case is constant because for the consumer, one bowl of basmati rice is always equal to the generic brand, and this does not change irrespective of where the consumer is on an indifference scale. Now, since the marginal rate of substitution determines the slope of an indifference curve, a constant marginal rate of substitution means that the slope is also constant. So for goods that are perfect substitute, their marginal rate of substitution and therefore the slope of their indifference curve is constant, which makes them a straight line. So what we can see here is if we are point A on this indifference curve U1, so this is point A, the consumer trades one bowl of basmati rice for one bowl of the generic brand. Now, if the consumer moves to point B on this indifference curve, the slope is exactly the same. One bowl of basmati rice to one bowl of the generic brand. Now, even if the consumer moves to another indifference curve, then the slope is also going to be the same along that indifference curve. And similarly for U3. So for any particular indifference curve, the slope along that line is constant, making them a straight line. If we draw an indifference map for perfect substitute, we will have a map that consists of straight lines with a negative but constant slope, as represented in this figure here. So we have U1, U2, U3, and all of them are straight lines. Even though the slope is still negative, it's constant along an indifference curve. Note that the diminishing marginal rate of substitution, it comes in play because the slope along the indifference curve changes and the rate at which the consumer trades one good for another, it diminishes as you move along the indifference curve. Now for perfect substitute, because the slope along the indifference curve is constant, there is no diminishing marginal rate of substitution. Now let's move on to perfect complement. So another extreme case is perfect complement, which represent goods that are consumed in fixed proportions. So let's consider a consumer who consumes tea and sugar. If this consumer consumes tea and sugar at a fixed ratio of 1 cup of tea to 2 spoons of sugar. So suppose this consumer is currently consuming a bundle per day, which consists of 2 cups of tea and then 4 teaspoons of sugar. This gives the consumer a level of satisfaction represented by indifference curve U2. So this is point A. Now, if you give this consumer an extra cup of tea, that moves them to 3 cups of tea, but you do not add any extra sugar. So you keep the sugar level as 4 and then give the consumer an extra cup of tea. That will only move him from bundle A to bundle B, which is still on the same indifference curve U2. So the only way to move this consumer to a higher indifference curve is to give him an extra 2 spoons of sugar with that extra cup of tea. So with this extra cup of tea, you give the consumer an extra 2 spoons of sugar, moving them to 6. So this 3 cups of tea and 6 spoons of sugar is now going to move the consumer to point C, which moves them to a higher indifference curve U3. Now, this is because for this particular consumer, he can only derive benefits from an extra cup of tea if it's only accompanied by 2 more spoons of sugar. Now, since the consumer only moves to a higher indifference curve if they have more of both goods and in fixed proportions, the goods are considered to be perfect complement. So, perfect complements are goods that are consumed together. So, an indifference curve for perfect complement is a series of right angle or L-shaped, as in the figure here. So you can see that U1 here is an L-shaped figure, and then U2 is also L-shaped, and then U3 is also L-shaped. The marginal rate of substitution in this case, and therefore the slope for perfect complement, is 0. Now, this is because the goods are not substituted for each other and they are consumed together. So remember that marginal rate of substitution, as the name denotes, is basically substituting one good for another. So for a typical case, as you get more of a good, you have to sacrifice the other. And for perfect substitution, this substitution is done at a constant rate. Now, for perfect complement, there is no substitution happening at all because you are not substituting tea for sugar or sugar for tea. You are consuming both of them together. And to move to a different indifference curve, we have to either decrease both goods or increase both goods. So there is absolutely no substitution happening here. So the marginal rate of substitution in this case is going to be 0. The next case is bad. So our examples so far have concerned commodities that are referred to as economic goods. Good in this case is that consuming more of it makes an individual better off. This is typical with regards to the non-satiation assumption. More of it is always better, so this makes it a good commodity. This is not always the case, as there are commodities that make us worse off when we consume additional quantities. So, for example, if you think of a commodity such as polluted air, when such commodities are called bad, and because more of them is not preferred, these goods violate the non-satiation assumption because less of pollution is preferred to more of pollution. If we draw an indifference map for two commodities, one considered good represented on our y-axis and one considered bad on our x-axis. So this figure shows that the indifference curve is upward sloping in this case. Consider bundle A on indifference curve U1, which consists of 4.5 units of the bad good and then 4,000 units of the good commodity. Suppose we have to make a trade-off between the two commodities. Let's consider the bad good as pollution and the good commodity as jobs. So suppose that the government has to make a trade-off between creating new jobs in the manufacturing industry, which implies more pollution, or creating less jobs in these industries, which implies less pollution. Now, the question here is, how many jobs will the government be willing to give up for cleaner air? Or how many jobs will we need to create to compensate for an increased level of pollution? Here we see that if we move from bundle A to bundle B on the same indifference curve U1, it implies less pollution, which is good. But to achieve that, we have to give up 1,000 jobs. So connecting all the bundles generated in this way will yield an upward sloping indifference curve U1, U2, and then U0. Now, assuming we move from bundle A to bundle C, we see that even though the number of jobs have not changed, which is still 4,000, less pollution automatically moves us to a higher indifference curve, which is U2. So in this case of bad commodities, upward sloping indifference curves implies that indifference curves to the left are preferred to those to the right, because anytime we move to the left, in this case, we have less and less of pollution, even if the good commodity has not changed. So this is all that we have on our lesson on other types of indifference curves. Our next lesson will be on utility theory, which is assigning numbers to indifference curves. If you enjoyed today's lesson, consider subscribing. Thank you.